Hey guys, welcome to video 4.
Where we'll be understanding wires and building a reaction time game.
Before we build, let's understand what the parts we need to use for the reaction time game does.
At the bottom of the microbit are pins. These are connection points where we can attach wires.
P0, P1, and P2 are input pins. That means they can detect when something happens, like a touch, and send that information to the microbit.
Ground works with the pins. It gives the electrical signal a path to return. When a pin connects to ground, the microbit recognizes that as an input. That is how the microbit can tell when something has been pressed.
With that information, we're going to move on to the first activity, which is the reaction time game.
So get your cardboard and tinfoil out and let's build our reaction time game. First, grab any cardboard you can find and cut out a small to medium rectangle. This is the base of your game.
Now, grab a sheet of aluminum foil and cut out 4 small rectangles.
Make sure you have everything before you start. The piece of cardboard you cut out, the 4 aluminum foil pieces, 4 alligator clips, a USB to USB-C adapter, a micro USB cable, the microbit, tape, and grab a pen or Sharpie.
Next, on the cardboard, outline where your microbit will sit. Then, draw 4 small rectangles, 1 in the top left and 3 along the bottom. Bottom left, bottom middle, and bottom right. Don't worry about being precise. These marks are just to show where the foil will go.
Then, tape 1 foil rectangle onto each of the 4 squares you drew.
Now you can name your reaction time game whatever you want. We're calling ours OpenCode.
Time to use the alligator clips. Grab any one clip and clip one end to P0 and the other end to the tinfoil on the top left corner.
Now grab another alligator clip, doesn't matter which one, and connect one end to ground and the other to the bottom middle tinfoil.
Now, take another clip and connect one end to the bottom left tinfoil rectangle and clip the other end underneath and to the back of the microbit to P1.
Now take the last clip and connect one end to the bottom right tinfoil rectangle and clip the other end underneath and to the back of the microbit to P2.
Great! You're all set up and time to code!
Alright, now that your reaction time game is all set up, you have your cardboard ready, the tinfoil's on, the pins are connected, head over to Make Code, and we're going to start the coding process. So make a new project and name it Reaction Time Game. The first step is to set up the variables. Before the game can measure anything, it needs a memory, places to store information as the round plays out. That's what variables are. Name containers we create and fill, like we talked about. This game needs 4.
Now, make a variable called false start and set it to false. This flag remembers whether the player jumped early. Now, make a variable called running and set it to false. This flag remembers whether a round is currently happening. Then, make a variable called start and set it to 0. This will store the moment the cue light appears. Lastly, make a variable called end and set it to 0. This will store the moment the player reacts.
The 2 numbers, start, end, are for timestamps you'll subtract later. The 2 true and false flags, false start, running, are for yes-no questions the code asks itself.
The second step is to work with when the pins are pressed. The player holds the ground foil with one hand and touches P0 or P1 with the other. Completing a circuit through their body is what the microbit reads as a press. We need 2 triggers, one for each pin, that wake up when their circuit is completed.
Now drag in an on-pin pressed P0 block. The code inside only runs when the player completes the ground to P0 circuit. This will start a round. Now drag in an on-pin pressed P1 block. Same idea, but it fires when the player touches P1. This will react and stop the round. Leave both empty for now. You'll fill them in next.
Step 3 is to create the countdown timer. When a round begins, the player needs a get ready signal, so the start isn't a surprise. We'll add a visible 3, 2, 1 countdown inside the P0 trigger.
Inside the P0 block, now add a show number 3. then a show number 2, then a show number 1. This flashes the countdown across the LED grid.
Now add a clear screen right after. This wipes the 1 off the display so the screen is blank and ready for the cue.
Step 4 is to work with Boolean, which is either true or false blocks. The player will run round after round, so each new round has to begin from a clean state. Otherwise, leftover state from the last round can corrupt this one. We reset the 2 flags right at the start.
At the top of the P0 block, above the countdown, now set running to false and set false start to false. This clears out anything left over from the previous round.
Step 5 deals with the random start. Here's what makes the game uncheatable. If the wait before the cue were always the same length, a player could just count it out and press in rhythm. A random delay forces a genuine reaction.
At the bottom of the P0 block, now add a pause block. And set it to 1000 plus pick random 0 to 2000. This makes the wait between 1 and 3 seconds, different every round.
In step 6, we're going to plot the cue LED. Now the round actually fires, but only if the player behaved and didn't jump early during that random pause. When it's a clean start, we light the cue and start the stopwatch in the same instant.
Still in the P0 block, after the pause, now add an if not false start then block. This makes sure the cue only appears if the player didn't jump early.
Inside that if, now set start to running time. This starts the stopwatch by grabbing the current millisecond count.
Now set running to true. This tells the rest of the code a round is officially live. Now add stop animation and clear screen to make sure the display is clean.
Now add plot X, pick random 0 to 4, Y, pick random 0 to 4. This lights one LED at a random spot. That's the go signal the player reacts to.
Step 7 is to deal with react and score. This is where the player's reaction gets caught and judged. The same P1 press means 2 completely different things depending on one flag. If the cue had already appeared, it's a real reaction, and if it hadn't, they jumped early. One if sorts them.
Now go into the P1 block and add an if running, then ... else block. This decides real reaction or cheat.
In the if running branch, the cue had appeared, so it's a real reaction. Now set running to false to close the round. Then set end to running time to stop the stopwatch.
Now add a show LEDs block and draw a success pattern. The project uses 2 filled bars on the left. Now add a pause 1000 so the image holds for a second. Now add show number and subtract start. This subtracts start time from stop time and displays the reaction time in milliseconds, so the score.
In the else branch, the cue had not appeared, so they jumped early. Now set false start to true. This flags the cheat, and that's the same flag step 6 checks before showing the cue. Show LEDs block and draw an X pattern to show too early.
Now finally, for step 8, you can make your game more competitive. Once you finish coding your own game, you can add a second player, so you can race head-to-head with someone else. Both players watch the same cue. Whoever reacts first wins.
To do so, now duplicate the entire P1 block, but make it an on-pin press P2 block with a different success image. Both players watch the same cue LED, and whoever completes their circuit first stops the clock.
Yay, you have now completed all the code for the reaction time game. Go ahead and download the code now that you have your reaction time game and all the code set up. Go play it, maybe grab someone, and have fun.